Hey everyone, and welcome to The Explainer. Today, we're doing something really exciting. We're moving way past those science fiction movies we all grew up with, and we're stepping right into industrial reality. We are looking at a profound, fundamental shift in how the world works, and it's all being driven by data, research, and hard economics. We are talking about the awakening of the humanoid robot. Think about this phrase for a second. Somewhere in America, a factory is waking up. It paints a really vivid, almost cinematic picture, right? But the thing is, it's not waking up with human voices or people punching time cards. No, it's a factory of machines powering on in complete synchronized silence. We're talking about machines that can walk and machines that can actually think. And according to the research, this isn't just a cool tech demo. This is the very beginning of what could be the biggest economic revolution in human history. And naturally, that cinematic reality brings us straight to the core existential question. The elephant in the room that brought you to this explainer today. Will robots take my job? Former U.S. Representative Will Hurd actually tackled this exact topic right after holding the first congressional hearing on AI. It is a completely genuine anxiety. And before we even touch the technology, we really have to look at the human element that's driving this entire conversation. Because the sheer scale of that anxiety is massive. Polling data shows that 65% of U.S. adults share this exact concern, that AI could lead to major job losses. So if you're sitting there feeling a little uneasy about the rapid rise of AI and robotics, you are absolutely in the majority. But to truly understand why these robots are being built at such a breakneck pace, we have to flip the script and look at the other side of the economic coin. As of early 2023, there were roughly 10 million unfilled jobs in the United States alone. Think about that number. And 7 million of those openings, they're for essential, everyday roles in warehouses, transportation, and retail. Yet there are only about 6 million people actually available to fill them. So this robotic revolution isn't just some scheme to replace humans. It's being driven by a massive structural labor gap that traditional automation simply cannot fix. Okay, so let's get into Section 1, the trillion-dollar market and the economics of the machine. A recent study by Roland Berger points out that we've hit this wild, unique convergence moment. It's basically a perfect storm. You've got roughly $10 billion in funding flowing in, massive tech ecosystems partnering up, and globally, we're facing a rapidly aging workforce. All of these elements are converging at the exact same time, and that is what's pulling humanoid robots out of the research labs and dropping them right into real-world deployment. Now, here is the number that is literally turning heads in every corporate boardroom right now: $2 an hour. That is the projected operating cost of an advanced humanoid robot. When you compare that to human labor costs in developed markets, the efficiency gains are just staggering. A machine that doesn't need sleep, doesn't get injured, and operates for a tiny fraction of the cost. The operational economics here are, without a doubt, transformative. So what exactly does a $2 an hour workforce do to the global market? Well, the projected market size for humanoid robots, just at the manufacturer level, is expected to reach up to $750 billion by 2035. And the projections don't stop there. By 2050, this market could easily rival the scale of the entire global automotive industry today. We are watching an entirely new industrial sector being born right before our eyes. Moving on to Section 2, Anatomy of a Humanoid: Hardware versus Software. To really wrap our heads around the brain of these new machines, we need to clearly distinguish between traditional automation and generative AI. Traditional robotic arms, the ones we've seen sparking away in car factories for decades, they operate on very rigid, predefined rules. They do exactly what they're programmed to do, nothing more. Generative AI, however, is a whole different ballgame. It actually seeks to replicate human cognition. It can learn from experience, adapt to messy, unstructured environments, and even come up with entirely new, original ideas on the fly. Now, there's a critical concept from Roland Berger's assessment called Mind the Gap. It shows us that the physical bodies of these robots, the onboard compute systems, the perception sensors, the skeletal structures, they are maturing incredibly fast. They're getting super close to a state that's ready for mass commercialization. But having a highly capable physical body isn't the final hurdle. there's still a really significant gap we have to cross. Because the ultimate bottleneck, it lies in the software. While the hardware is gearing up, the brain of the robot, specifically these things called vision language models, that connect what a robot sees to what it actually does, that software lags about 3 to 5 years behind the physical tech. You see, generative AI needs massive amounts of real-world training data. We have plenty of text data on the internet to train chatbots, sure, but we severely lack the physical, spatial data required to teach a robot how to navigate a chaotic, unpredictable human environment. Which brings us to Section 3, the global robot race and these two scaling curves. Globally, we're seeing two very distinct strategies emerge in this race. In the West, mostly North America and Europe, there's an AI-first approach. This strategy is highly capital-rich and laser-focused on building the absolute smartest software and foundation models first before they ever really scale up production. Conversely, China is using a deployment-first approach. Their strategy is completely volume-led. They want to build the hardware rapidly, deploy it out into controlled environments, and use that massive real-world deployment to gather the exact physical data needed to train the AI. And when we look at the projected production units for 2025, it visualizes this stark contrast perfectly. China's manufacturing deployment is aiming for roughly 15,000 units. Now compare that to the Western ecosystem, which is projected to produce just a few hundred units. It's an incredibly fascinating race. You have the West's deep capital and software expertise going head-to-head with China's massive industrialization and data-gathering flywheel. All right, let's bring it all together in Section 4, the blueprint for coexistence. Let's start with a little historical perspective to ground us. From angry weavers physically destroying the spinning jenny back in 1764 to the very first Unimate robot in 1959, all the way to IBM's Deep Blue beating a chess grandmaster, humanity has consistently faced these massive technological leaps. And yes, jobs changed, of course they did, but we adapted and we moved forward. The leap to generative AI and humanoids is undeniably monumental, but adapting to disruption, that is literally woven into our human history. But to successfully adapt this time around, we need highly targeted strategies. First off, we absolutely must cultivate a workforce ready for this shift by heavily investing in STEM education and vocational training that complements AI. We need to be teaching skills like complex problem solving, things that machines still really struggle with. Secondly, from a security standpoint, as AI gets more and more powerful, our cybersecurity defenses have to evolve to become AI-based as well. It's going to be a high-stakes battle of good AI versus bad AI. But education and defense just aren't enough on their own. We desperately need a solid ethical AI framework. And the steps for crafting this involve enforcing radical transparency in how these systems actually make their decisions, legally guaranteeing that individuals own their own digital data, and here's a big one, as these models become exceptionally powerful, we'll likely need regulatory licensing just to operate them, kind of similar to how we currently license and monitor nuclear power plants. So if you take away just one core thing from everything we've covered today, let it be this. The future of work is not humans versus AI. It is humans with AI. We really have to view this technology as a highly capable tool designed to augment and enhance our own human capabilities, not just a replacement to be afraid of. We provide the creativity, the context, the empathy. And the machines? They provide the speed, the heavy lifting, and the precision. Which leaves us with one final, profound thought. The technology is already here, guys. The factories are waking up right now. The hardware is maturing, and the software is learning at an exponential rate. So the question is no longer if intelligent humanoid robots are going to join the workforce, but rather, are we ready to evolve alongside our creations? Thank you so much for joining me today, and I will see you in the next explainer.